Has anyone used the DeepLens? Okay. So you might understand some of my frustrations as we go through this talk then. Okay, so just a bit of background about me. I am originally from King's College. I didn't do a background in computer science at all. I was actually medicine and genetics, which is far removed from this altogether. But I did do a lot of data analysis and some programming, which led me naturally into more of the cloud. So I moved on to CloudReach, and CloudReach did what we call the fast track program. So it's a 12-week intensive course to teach me everything about the cloud and then dump me on a project. And that was brilliant, and it gave me all the skills I needed to get going and to learn what I needed to learn. Now with Nubigo, doing much of the same, so development projects and training, and actually going to companies and teaching people how to use the cloud, particularly AWS. So 5 facts about me then. I have a dog that looks like a wolf. Bit of a lame fact, but it's true. I used to be a zookeeper at London Zoo, which was pretty cool. I once sang on stage at Disneyland Paris with my choir. I was once on TV, not as somebody who lost a lot of weight, but as someone who was a scientific expert on the gut and microbes. But thankfully we can't find that episode. It no longer exists on the internet, much to my joy. And then the final one, which isn't really a fact, I think most people in here would probably agree with it, I love craft beer. So later on maybe you can grab a beer with me. So, why are we all here? I think most of us are here for this top thing, right? We're all here to learn something new. We're going to be, in this talk, learning very high level about machine learning, and I mean high level. You've heard some great talks this morning about machine learning, one which went into quite a lot of detail, and one which was amazing about the media. So mine will stick quite high from that. And then we're going to talk about the DeepLens and how machine learning really works with the DeepLens. So I'm going to take you on my journey, and my journey is filled with lots of twists and turns, maybe not exciting, but still very much there. And it begins with the DeepLens itself. So a few months ago, we got the email through that the DeepLens have been finally released in the UK. Now, for anyone who actually knows about the DeepLens, I'll know that it was available in America for a while. It was announced at reInvent, and the US had sort of prime access to it, really. And I guess they were sort of an experiment. They were used to determine how useful the DeepLens could be, and whether or not there were any kinks they needed to work out in the device. They worked out those kinks and presented us with version 2, which they released here and several other countries across Europe. Now, me and my boss, Fernando, who's at the back of the room, tend to be on the same wavelength on these types of things. So at the same time, we both messaged each other asking if we should get one, and that was the answer. So 2 days later, thanks to Amazon Prime, we ended up with a DeepLens on our desk. Great. What are we going to do with it?
On that cliffhanger,
yeah,
which is brilliant, Dave is just going to try and sort out an extra microphone for you.
Okay, perfect.
Okay, so we're going to do this on the fly. Do you want to come and do that, Dave?
Right. So we need to figure out what to do with the DeepLens. Okay, so we had some ideas. We had some brainstorming in the office. And we're not really very creative, we figured out. So we came up with things like a pub quiz for AWS terms. There's a few of us in the office that are trying to accomplish cloud practitioner. Come on, Lenny. Or are trying to pass some certain certifications at the moment. So we thought maybe a nice little pub quiz with the DeepLens might help. We have offices in Spain, so maybe a Spanish learning game would be fun. An office assistant, pretty cool. Maybe something that could sign people into the office and out as they entered and left. Or Pictionary. Pictionary seemed the most fun, to be quite frank. What I did learn, though, is everybody has done these before. There isn't a single unique idea on there, which is perhaps not so surprising. Okay, so we went ahead with Pictionary. Didn't really know where to go from there. So we knew that we'd need a lot of images, and we knew those all needed to be labeled. And I also knew that my colleagues were not going to help me draw thousands of doodles just so that we could play a game of Pictionary with a machine learning camera. So we're going to start talking about that journey and how to move on to the DeepLens. So this is Lenny. He did a photo shoot for us so that we could show you this, because you can't obviously see all this up front here with him set up. So Lenny comes with the camera, or the DeepLens, I should say, comes with the camera. There's 3 lights on the front that you can see. Now, all 3 of those should be lit up. Please tell me if they're not, because that means something's gone wrong. The top one is the camera status light. So that basically tells you, is your model running? Is it there? Is it picking things up? It's a really useful light in the first stage of your debugging. Second one's just Wi-Fi. Is it connected? And the third one is your power. Now, obviously, you've got your power button underneath. And then on the back, which I can't turn around and show you, but you've got a micro USB port, so that's your storage. A micro HDMI port. You might be wondering why you'll need that, and I'll come to that a bit later on. 2 USB ports, one of which is necessary for registering the device. Your audio output, which is what we're using right now for the speaker, and then obviously your power port, which it does not work without wired power. It has to be connected. So bear that in mind if you want to start using it walking around fields. You're going to need a power pack. Now, it does integrate with pretty much all of AWS. So if you're thinking about your serverless architectures, Lenny can fit into that. So it and basically underneath, it's running with Greengrass and Lambda. So you have your model that you've created, and then you have your Lambda, which executes that model for you. So anything that Lambda can trigger, or anything that can trigger Lambda, can work with the DeepLens. So you're thinking things like S3, Poly, which we've used, SNS, DynamoDB, and everything integrates really well. So now we're going to go on to a little bit about machine learning. I am not a machine learning expert. I have a data analysis background, but that has not yet transpired into machine learning. And I wanted to start learning machine learning, which is why we went down this route. Initially, it began with a deep racer, but we can't get hold of one of those at the moment, so we sat that off pretty quickly. And we moved on to the DeepLens instead. And AWS markets the DeepLens as something to get everybody involved with machine learning, to take you from no knowledge at all to being able to deploy your first project within 15 minutes, which seemed like a pretty cool thing to try and test out, really. That said, my lack of machine learning experience probably contributed to half the problems I had during my experiences. So what is machine learning then? Well, essentially, it's a bunch of algorithms that you can use to learn information from your data and then apply that to other data sets. There are many sort of frameworks out there that you can use, some of which you've probably heard of before, like TensorFlow or ResNet. And you've probably all used machine learning before. So if any of you have an iPhone, for example, at nighttime, when you plug your phone into power, in the background on the phone, your phone is doing machine learning on your photos. It's applying labels, and it's trying to figure out what you've got in your photos. And really, it's just to make sure that that's easy for you to find your photos. So if you go into your Photos app and search dog, you'll get a bunch of photos of dog, if you've taken photos of dog. Sometimes it miscategorizes things. There's a lemur there. Lemurs aren't dogs. Kind of look like dogs, not the dog. And you can't correct those labels. So it's kind of limited in what it can do, but it's something that has been happening on your phones, probably without most of you even realizing. if you've got an Amazon Echo or any of the Echo devices, that's all machine learning. And Nest and Ring doorbells, they're doing machine learning in background as well, learning faces, learning who's approaching your door for future use. Now, as you heard in the first talk this morning, there's sort of three main branches of machine learning. So we have supervised learning. And this is where we have a few photos, and we know what those photos are, so we label them. So we've got dogs, kind of a dog, maybe a polar bear, we don't know. And you feed this into your model, and it will then learn what the characteristics make up a dog, and then you can apply that to some new photos. Yeah. So now if we throw it a photo of a cat and a swan, it'll know that that's not a dog, we hope. And it'll put the dog into its own category, which is a dog. Now, unsupervised learning is where we don't necessarily know about what's in those images. We don't have those labels. We don't have that knowledge. And so the model will then go ahead and try and figure out what defines each of those photos and what makes them similar and group them together. So hopefully, in this scenario, you would get a group of dogs and a group of cats. I mean, that middle one could well be a cat the size of its ears, but we'll have to leave that to the model to decide. And then finally, we've got reinforcement learning. Now, how many of you have used the Deep Racer? Okay, cool. So the Deep Racer is a machine learning car. Very little use to it beyond racing and learning machine learning. But it learns using reinforcement learning. So what you could do with the car as it's driving around the track, you can divide your track into sections based on the center line. And if it stays close to the center line, you can reward it with points. And the further away it gets from the center line, you can reward it with fewer points. The idea being that the more points it has, the better it's doing, and therefore knows generally where to stick to as it's going round. It's actually quite fun to watch in the console. You've just got this little video of a CGI car going off terrain quite a lot and frustrating you, especially as you're watching the dollars tick up as it's costing money. But think of reinforcement learning more like training a dog, training a puppy. You want it to do something, so you give it a reward. And it's exactly the same. So with that in mind, and with all that background, we decided now was the time we were going to learn how to do a Pictionary game on Lenny. And after some Googling, I realized I didn't have to make my colleagues go and draw thousands of doodles, because somebody had already done it for me. Google have an open source project called Quickdraw, where they created a game which got people to draw doodles of things that they were given, kind of like Pictionary. And they did this purely to see if neural networks could recognize the images. This was great. I didn't have to go and draw loads of things or scour Google for doodles. Now, obviously, everybody draws differently. And so when you're adjusting your pictures, you need to make sure that everything's on the same coordinates. Essentially, what this model was doing was drawing everything up into pixels, and wherever a pixel had ink, it would then mark that as filled. So you essentially got a JSON matrix of what did have something and what didn't, in order to get the outline of the drawing. So this was all great, and there was a tutorial, even better. I've never done machine learning, but there was a tutorial in Tensorflow that has all the code. I just need to figure out how to put it onto AWS. Brilliant. Now, Tensorflow is open source, so anyone can use it. They don't have to pay, and it allows you to start building layers upon your machine learning models. It can be run pretty much anywhere. So the entire point of Tensorflow was that you could run it on any device which could handle that computation, whether it be your phone or your computer or the cloud. It does have visualization tools in line with it, and it's got a really good community around it. So if you do get stuck, there's plenty of people who are there to help you, which makes TensorFlow a really attractive option for people just getting started into machine learning. Not for me. So I didn't understand anything about TensorFlow, and TensorFlow has its own language. So it's based in Python, but there's a sort of some syntax that if you're not familiar with it, it can just lead you around in circles. Now, as part of a SageMaker model on AWS, you can import TensorFlow script. And you can either do it in Amazon's specific outline. where they have a specific set of definitions that you need to include. Or you can do what they call script mode, where you just port your code in. If you port your code in, there is an extra little section that you need to include just so that it executes the code. And that was that extra little bit that I couldn't write because I didn't understand what was going on all the way up at the top of the code. I didn't know what a tensor was. And not being able to understand that had me stuck. I couldn't go any further, not in the time allotted anyway. I need to go back and learn TensorFlow, which is fine. I shouldn't have been arrogant enough to think that I could go straight in and learn something entirely new within a week. Okay, so I thought, well, the DeepLens does come with some projects that come preloaded that you can actually start to learn how to use it before you start going off and doing your own projects. It seemed a little bit better and a little bit more entry level for my abilities. So these are the current sample projects that they currently have on board. Anybody a Silicon Valley fan? The TV show? Yeah. They did do the hot dog or not dog. Again, limited uses there. We're not the only ones that aren't original in our ideas, apparently. But you can do object detection, so it'll detect things like a bottle or headphones or a chair or a table. It was only about 50% sure that one of my colleagues was a person, which is a little bit worrying. But it can also do face detection, or cat or dog detection. But for this one, I decided to go with bird detection. So AWS did have a competition in place, which was to see what everybody in the community could come up with in terms of their originality and creativity. And there were some really good projects that came out of it from the DeepLens. So some used it for sign language translation, so that people could understand what a deaf person was saying. Other people used it to do dog detection on walks. Again, not sure how that works with the power. I'm guessing they had a power pack. But this one was probably my favorite, which was an AWS project manager who was really sick of his cat coming home with various bits of prey, leaving mice and birds in his kitchen. Yeah, he had to clean up after it, and it was just getting really annoying. So he used the DeepLens to ban his cat from the house if it was bringing home a mouse or a bird. And it worked. There was a whole video on it about his journey and how he created it, and many funny images of the cat being very flummoxed by the fact it couldn't get through its cat flap, and just leaving the items in front of that instead. So that's probably one of my favorite uses of it so far. Mine's a little bit less fun than that, but all the same, we'll go ahead. Right, so the birds classification. 11,000 images, more than 11,000 images for about 200 bird species. It's a lot of data. The problem that I had with this was that I hadn't looked at the list of birds, and they're all very Americanized birds. They're from Caltech. So they're all very, not birds that you would necessarily see here. So when I was trying to test it with a robin, robin didn't come up. So I had to go in and figure out which birds were available. So this is a publicly accessed data set that you can all go to if you want to. This is the latest data set with 11,000 images, and there is a small one with 6,000 images if you wanted to check that out. So essentially, this model comes preloaded. All you have to do is go into the DeepLens console and go deploy project, and then select project, and off you go. But I wanted to learn more about the process. So I went through the tutorial of how to actually put this model together and train the model using Amazon SageMaker. Now, SageMaker is the machine learning platform on AWS. You essentially, has everybody heard of Jupyter? Good. So Jupyter is, again, open source, which allows you to execute code, but in sort of a document fashion. So you can document everything as you go through, have code blocks, text blocks, really good for collaborative learning and just collaboration in general, really. So with SageMaker, you can create a Jupyter notebook and define your models via this Jupyter notebook, and then define the endpoint at the end for your final model. And that's essentially how it works. So for this classification model, we first wanted to reformat the images. So same with the Quickdraw example. You want to make sure that all the relative coordinates are the same, that they're all operating on the same size picture. Then you define your hyperparameters like how many times do you want to iterate over the same pictures, things like that. And then you actually define your model. You define whether you're using a neural network or whether you're using regression. And then finally, you go ahead and then train that model. And that's where the cost comes in. That's where you're using your GPUs to train your model. And for SageMaker, and for this example in particular, it does have to be a GPU. So then I sat down and I was like, well, how is it all going to look at the end? There's no point me doing this reactively. I should really architect my design and figure out what's triggering what. So I had Lenny, and he was feeding some images. And that was supposed to then trigger a Lambda function, which was the model function, which would then output a picture to a bucket, which would then trigger another Lambda function to create some speech, which would then come all the way back to Lenny eventually. And this was kind of like a game of snakes and ladders. As with any development game, not development game, but any development project, right? You go 2 steps forward, 1 step back, trying to figure out what's going wrong, where the bugs in your code are. And this was exactly the case here. Every time I thought I'd made a step forward, I was actually back to the drawing board, which was kind of fun in a way, a bit of a challenge. But still, eventually I was making progress, and I got to that final stage where I had my sound. I just needed to figure out how to get Lenny to play it, because Lenny doesn't have a speaker on board. And so I knew I had to plug in an external speaker, and that's fine. But how do I get it to work when the sound's sat on S3 and Lenny is here? It turned out that my architecture was wrong. I'd fundamentally misunderstood what happens with that model Lambda function. So the Lambda function itself doesn't run on AWS. It runs on Lenny. It runs on the box. This box has a GPU, so it can do that. And so essentially the Lambda function is running on the edge, which meant that I had to make sure that my sound was being created and then being played via that same model script that I'd used to trigger the model in the first place. So in reality, this is what my architecture looked like, a lot more simplified. We would have a picture being shown to Lenny. That would trigger a Lambda function, which runs infinitely, by the way. It's not sort of a defined end. No! The DeepLens model would then trigger Poly, create the sound clip that I wanted based upon the logic required, and then put that back out to Lenny. Now, DeepLens, as you saw, there's not many people in the room who have used the DeepLens, and that is true of the entire world. Normally, if you have a problem with your code, you Google it, you Stack Overflow it, you even Reddit it. You can't do that with the DeepLens because no one's really used it. So it was really frustrating. Every time I had a problem, I sort of had to muddle my way through it and hope for the best, because there was just nothing out there. And if there was, there would be one obscure answer that was similar to what you wanted, but that had been patched in the recent update, so that wasn't your issue. So you were constantly trying to figure out what was going on, and I'm a prideful being. I don't like asking for help. So I didn't want to get in touch with AWS to try and figure out what was going on. This is one that has still not fixed. If you turn off the DeepLens device, at least this DeepLens device, it could just be he's moody, it won't come back online again. And if it's not online, you can't deploy anything to it, you can't run a model. The only way to get around this, I've found, is to deregister the device, re-register the device, and start from scratch, which is a clunky way of doing it. And that's definitely one I am going to need AWS's help to solve, because this is beyond my capability completely. When you first want to run sound on the DeepLens, you need to download some packages. And the easiest way to do this is to log into the DeepLens, which is essentially just an Ubuntu computer underneath, and try and play an MP3. And then when it says, you need these packages, say yes. Which is why it has that micro HDMI on the back. You need to plug it into a screen, plug in a keyboard and mouse. It's only got the 2 USB ports, though, so you need to do that via a Bluetooth dongle that has both. And do that. But when you set up the DeepLens, it has an SSH key that you define. So I defined that. I knew exactly what it was, the nicely secure hello Lenny. And when I was typing it in, it wasn't working. I couldn't for the life of me figure out why. It was exactly the same. I tried the default one, which is AWS_CAM. Wasn't working. I was locked out of this device, and now it was useless to me. Turned out the Ubuntu is on the American keyboard, and the @ key is in a different location. So my boss quite helpfully figured that one out for me after hours of me trying to figure it out. He did it in minutes. So yeah, always never have ats in your passwords, I guess, is what I've learned from that one. And Lambda function woes. So obviously it's a Lambda function that's executing, but when I was checking the logs for what was going wrong, this isn't a Lambda function, this ggrouter function, that I've even heard of. It is not one I created. It's obviously being triggered by something elsewhere. And there was a problem with it. I had no idea what it was. It turns out this is when I realized that the Lambda functions are being run on the device and not actually on AWS. So once I logged into Lenny and then did some troubleshooting there was a package, python-gi missing. Reinstallation of that fixed it. But again, nothing on the internet about this, absolutely nothing. It was just lots of trial and error. So, I know some of you have seen this already, accidentally at the beginning, but we're going to do a demo of this now. And there's new people in the room now who haven't seen this, so it's going to be a shock to some people, hopefully. Right, so you can see my screen, which is good. So this is the DeepLens console, and this is where I've got my model already loaded. I can deploy a project or I can remove a project. It takes a few minutes for a project to load. So it's not an instant thing, and even when it says the deployment has been successful, it then still takes a few seconds for it to start really working, okay? What you can do is a video stream. So you can see all your lovely faces there. And right now, it thinks you're mallards. Sorry. So right now, it's looking at all of you and trying to figure out what birds you are. It's not going to do a very good job of that. But thankfully, it's not got a very high prediction. It's only thinking that you're 2.9% blue jay at the moment. Now, essentially, what this is doing is every frame of this video feed, it's analyzing to figure out which birds are in there. So it's taking every frame, putting it through the model, and then returning what it thinks is in that picture. This blue square here is the only bit it's really taking any attention to. So I am going to try and line up to that picture, okay? He can be very temperamental, and it all depends on the lighting of your phone, whether or not you've got a shiny phone, but we'll see what he does. Please work. I'm pleading with you, Lenny.
Well, I'm not very sure, but I think it might be a Bohemian waxwing.
He's right. Okay, let's try another one.
Well, I'm not very sure, but I think it might be a ruby-throated.
So that's,
Well, I'm not very sure, but I think it might be a ruby-throated.
It's a ruby-throated hummingbird. Obviously, I only have 2 things in my dictionary, so I need to change that. This one he's very temperamental on, so we'll see how he does. Come on, Lenny.
Well, I'm not very sure, but I think it might be a white pelican.
Yes.
Well, I'm not very sure, but I think...
Now, he can be very temperamental, and as I say, it's all down to the lighting. And last night we were trying to film a video to just make sure that if this didn't work, I had something to show you. And it took half an hour for him to just recognize the one that he got immediately within seconds. Not all things are made equal with this. And I think that's definitely something to take away, that it requires a lot of perseverance. So thank you, Lenny, and thank you, demo gods, for working. So I'm not going to keep you much longer. I'm just going to quickly...
30 seconds.
That's fine. So just things that I've learned. Don't go into Tensorflow if you don't know Tensorflow. Go from the beginning. Don't make my mistakes. He really tested my resolve. I wanted to throw him across the room so many times, and humanizing him only helped a little bit. But more importantly, the DeepLens has huge potential. It's being used to diagnose cancer. It's being used to see if psoriasis is getting worse. It's being used to give dementia patients knowledge of who's visiting their homes. We've used some frivolous examples here, but that's definitely not the limit of what the DeepLens can do, and it can certainly do a lot more. So I do encourage you to go out and get one and start experimenting and see how you can apply it, because I do think in time it could be a very useful device. So thank you for listening. I said it earlier that I'm with Nubigo. We are hiring at the moment, so if you're interested to come and start playing with cool things like this, do come and talk to us. There's me and there's Fernando. And do get in touch if you've got any questions.
Wonderful. Really cool. It worked. That's amazing. Yeah. Right. Any questions? Can I just, if everyone can hear your question?
Yeah, I just want to ask about the price.
Okay. So when we got it, it was about $200, I believe. I'm not sure how that's changed since we got it. It's probably about the same. $150 to $200. Yes.
Hello. Can Lenny tell you how he's making his decisions?
Lenny could tell you anything you want him to tell you, because essentially it feeds into Poly. So if you can create the sound clip.
What I mean is, it looks at an image and it gives you a result.
Right.
Does it give you feedback? I decided it's a blue-footed booby because...
No. So you don't, well, currently the model itself doesn't have access to sort of the labeling system that it uses. It's literally just sort of looking at the images and figuring it out. With some development, you could probably get the model to output the labels that it's applying for the certain points.
I'm more can sort of describe this process. I have decided this is this species of bird because of these characteristics in the image. Can it tell you that?
So at the moment, no.
Okay.
Okay, so you would need the metadata for how the model itself is assigning the labels to the image, and if you can get to that, then you could then go ahead. So there's a website, on the Caltech website actually, for the birds. There's a load of images that have already been pre-labeled, so you can see how the model labels the images, and some of it is just, this has a purple bit here, this has a white bit here, it has a peak here. And essentially that's how the model starts to label the differences between the photos. And so you can start to see that on the Caltech website. Now, if you can get access to that data, figure out how to develop that, then you could then get Lenny to output that. But it's getting access to that metadata, really, that's your first step to getting that.
Just to make sure I've got this right, you didn't train the model was already trained with the data. What you're doing with Lenny is inferent on the device.
Yes,
on the edge.
Exactly, yeah.
Okay.
So I did go through the process of training a model for the bird classification project, but that wasn't the model that got deployed. The model was the one that comes in the box with AWS. But yeah, my next step will be the Quickdraw one, because that's a lot quicker. Not quicker, but a lot more fun.
Okay. I think we'll have to, Michelle is around
All day?